Okay, a rational function. Right, here's what we have right here. Okay, now there's different ways of looking at this. You can do these in any order. Okay, I happen to think that the y-intercept is one of the easy ones, because when x equals 0, think about it, all you have is -2 at the end of the numerator and -9 at the end of the denominator. So that y-intercept is 0 to 9ths. That's the y-intercept because x equals 0. Okay. Right, let's take a look at some other things. Now, the horizontal asymptote. Well, there's different rules for horizontal asymptote. If I say okay, right now, the leading term, 2x squared over x squared. Supposing I had 2x over x squared. Supposing I had 2x cubed over x squared, okay? Right, so this is what it actually is, so I'll come back to that one. When the denominator is a higher degree than the numerator, it's always y equals 0. When the numerator is a higher degree, okay, not a lower degree, when it's a higher degree, then that is a slant asymptote, okay? So it's not horizontal, it's a slant one, which we're not covering in this particular test. Now, when it's the same, which I have here, okay, it's just the leading coefficient over the leading coefficient at the bottom as well. That's 2. So the horizontal asymptote is y equals 2, okay? Now then, the difference between the vertical asymptotes and the x-intercepts. The vertical asymptotes are the denominator. Look at the denominator. The x-intercepts is look at the numerator, okay? So the vertical asymptotes, let's take a look. If I look at the denominator, it's x squared minus 9, okay? Now, this is going to come in with the domain as well, because remember, you can't divide by 0. So really, answering the vertical asymptotes is also answering the domain in a sense. Okay, if I do that, I'm going to get vertical asymptote of x equals 3 and x equals -3, okay? If you want to add a 9 in square root. Okay, so the domain also then, if I can answer this right now, if that's the vertical asymptotes, then the domain is this, -infinity to -3, and then -3 to +3, and then 3 to infinity, because I cannot have -3 and +3. Those are the vertical asymptotes. I'm going to put some of these on now. Right, let's look at that. The horizontal asymptote is y equals 2. The vertical asymptotes are plus and minus 3. Right, the y-intercept was +2 9ths. That's hard to draw. It's just a little bit above the 0, 0 point, okay? Now, the x-intercepts, remember, is the numerator, okay? So, again, if I end up solving the numerator, 2x squared minus 2 equals 0. I could factor 2 out, call it x squared minus 1 equals 0. Well, that looks like plus and minus 1. Okay, so 1, 0, and -1, 0 are my x-intercepts. So I'll put that there, and that there. So this is probably what that looks like, okay? Remember, you can approach the verticals but not touch them. Therefore, if I was to check elsewhere, suppose I was to pluck some more numbers in, I'd have something else here as well. But you can also check on your graphing calculator, and that would be the answer to that, okay? Right, let's look at the next one. Okay, inverses. Right, remember this? Call this y equals log base 2 of x minus 1. Swap the x and the y around. That's base 2. Okay, so I'm going to change this from log to exponential. Remember, that's the inverse. An exponential the inverse of a log is an exponential. The inverse of an exponential is a log. So here we go. 2 to the power x equals y minus 1. That's me converting from log to exponential. All I need to do now is add the 1. So y equals 2 to the x plus 1. Or remember this inverse notation, f minus 1 of x equals 2 to the x plus 1. Okay, so that's that. All right, let's take a look at the next one. Okay, so again, I'm going to change everything round and say this is x equals y minus 4 over 3y plus 2. Okay? Best thing to do is to multiply by the denominator to get rid of it. So 3y plus 2 times my x is going to equal y minus 4. Okay, because I just got rid of this on the right-hand side. Let's do the distributive law on the left. 3xy plus 2x equals y minus 4. Okay? Right, so we want to get to y equals, so we want to get the y's on the same side. So I think what I'll do is I'm going to take away this y from both sides. So 3xy minus 1y, and I'll take away this 2x, so that equals negative 4, negative 2x. So again, I've got the y's on the same side, so I can now factor it out and get this. Y, 3x minus 1. Think about factoring a y to this division, that's 1 left, okay? Y divided by y equals negative 4, negative 2x. I would then just divide by this thing next to the letter I'm looking for. And that, folks, would be the inverse, okay?